Hi, my name is Ammar Yasser. Today I will explain the conic section hyperbolas. First of all, we have the horizontal hyperbola. The horizontal hyperbola, its center, it's uh, h and k. It doesn't matter what is the value of h or k. So the center is h k. So here in the hyperbola, this is the center, which is 0 0 0 0. 0 is the h and the 0 is the k. Here the vertices of this hyperbola, it's located here. This is v1 and this is v2. The distance between the v1 and the center is called a, and the distance between v2 and the center it's also called a. So the distance between v1 and v2 is called transverse axis, which is equal to 2a, a plus a. And the foci of the hyperbola is located here. This is f1 and this is f2, and the distance between f1 and the center is called c. Distance between f2 and the center is called also c. So here, as what we can see, c is greater than a. So in the hyperbola, c is always greater than a. So what we can conclude here, that v equal to v1 is equal to h plus a, and k stays same, and v2 is h minus a k. K stays the same. Also the f1, it is h plus c, because c is in the same axis of x, and k stays the same, nothing changes. And f2 is h minus c, k stays the same. The b value is located here, the line that is perpendicular to the transverse axis. It is here. So this is the co-vertices CV1 and CV2, and the distance between the co-vertices and the center it's called B. So this is B. It doesn't matter that B is greater than A or A is greater than B, but here C is always greater than A and greater than B. So the Pythagorean theorem here is it is C squared equal to A squared plus B squared. So and as we can see, CV1 it's equal to h stay the same, but k changes because here it is in the y axis. So k plus b and CV2 equal to h k minus b, and the distance between CV1 and CV2 it's called conjugate axis, which is it is perpendicular to the transverse axis. So here conjugate axis equal to 2b, b plus b. The equation of this hyperbola, it is x minus h squared over a squared minus y minus k squared over b squared equal to 1. As it is horizontal hyperbola, so a squared will be under the x minus h squared, and b squared will be under the y minus k squared. So, and always there is a negative sign. If it is not a negative sign, it is not a hyperbola. And in this hyperbola, it's also have a asymptote. The asymptote equation of this hyperbola is y minus k squared equal to b plus or minus b over a x minus h squared. This is the asymptote where the graph does not exist, where the graph it is undefined. This is where it is negative this, and here it's positive. It's also have the eccentricity, which it is c over a. Here it is asymptote, here it is eccentricity. Here in the vertical hyperbola, nothing will change except the direction. V1 will be here and V2 will be here. Sorry, because the drawing is not good. And the center will be here. CV1 will be here, CV2 will be here, the F1 is here, F2 is here. As we know, distance between V1 and the center is called A, and F1 and the center is C, and CV and the center is B. That's it. So V1 is HK plus A, V2 is HK minus A, CV1 is H plus B, because B is on the x-axis, so we add the H at the H, and here we add A to K because A is on the y-axis. Also C is on the y-axis, so H stay the same and K plus C. That's it. This is the asymptote. The asymptote is located here. So the asymptote is equal to A over B, not B over A, it's A over B. So this is positive asymptote and this is negative asymptote. Here the transverse axis is the distance between V1 and V2, same as the hyperbola, the horizontal hyperbola. And the conjugate axis is the distance between CV1 and CV2, which is perpendicular to the transverse axis. Here C is still greater than A, so the Pythagorean theorem is c squared equal to a squared plus b squared. The equation of this hyperbola, it is y minus k squared over a squared. Because it is vertical, so the a squared will be under the y, minus x minus h squared over b squared equal to 1. Question 2 is about the hyperbola, and it's asking to write the equation of asymptote of the hyperbola. So this is a horizontal hyperbola. So the equation of the equation of asymptote of the horizontal hyperbola is y minus k equal to plus or minus b over a x minus h. So here b it is 3, and a it's 2. So the most true thing is it is here, because b is up and a is down. It's here x plus 3, and here it's y. Here it's asked to write the equation of that represents this hyperbola. So here we need to find a and b. First of all, we have the center, which is 2 and 1, and a is the distance between v1 and the center, which we count from 8 to 2, it's 6. So 8 is 6, and b, it's the center between this point and the center. The distance between this point and the center, it is exactly right here, which it is from 3 to 1, it's 2. So this is b. So now we have a and we have b, and we have the center, so we can find the equation of the hyperbola. So x minus 2 squared over 36, a should be squared, minus y minus 1 squared over 4 equal to 1. So this is the right answer.